All right, so today we're going to talk about what is the data cloud and why is that so important. So just a brief introduction about myself. My name is Stephen Moon. I'm Principal Data Platform Architect with the Office of the Field CTO at Snowflake. So we work with solving some of customers' hardest data and analytics problems through the Snowflake data platform. And today we're going to talk about the data cloud and why that's so important to a customer's modern data organization. So first, a lot of people have probably seen this before and are familiar with the problem that we're trying to solve, right? We have data silos that still exist today. We have, your traditional transactional systems, ERPs, sales, finance, but a lot of the data silos today are also being created by data that's being generated through web logs or IoT devices. And even with the advent of the cloud, there's still a lot of silos that exist, right? Just because a customer may migrate to the cloud doesn't mean they're not going to have silos of those data. And so when you go to access that data, there's difficulty in joining, augmenting, building an ontology of that data. How does it relate to each other? It can limit to insight and understanding. It can lead to data governance nightmares. We often talking about complexity as the enemy of security. And so I have to have a different security model for all of my data, or different identity and access management model for all of my data. That can be increasingly challenged to manage. It can also be increasingly challenged when I have to integrate that data. And especially when you think of things like zero trust and some of the other CMMC and some of the other accreditation things that are coming out, that's going to be all that more important. And then the high cost of managing those systems, right? And so I have to have a skill set across a number of different technologies, right? It could be, big data systems, NoSQL systems, or all the different places where my data really reside. And so all those things really have exasperated to a certain extent with the explosion of data within the last, 5, 10, even 2 years. Where the data is still not only siloed, but there's just an enormous volume of siloed data, even in cloud deployments. And so a brief history of the data cloud, right? So, a lot of companies are now really building cloud native architecture. So you think of the landscape out there, people are building on cloud platforms like AWS. And so you originally had a cloud data warehouse, right? You're taking, the concepts of a data warehouse on premise and then building that natively in the cloud. And then you start looking at the cloud data platform, right? As the advent of data lakes and the convergence of those with data warehouses, it's not necessarily, those are two separate things anymore. So you think about your data lake and your data warehouse converged into a data platform. And then the data cloud that sits on top of that data platform, within the last year, we're going to talk about this in a minute and show some graphic slides that are really interesting and show the impact. The network effects of data, not within your business, but within the community itself. And we're going to show how the data cloud can really accelerate that growth because of the network effect. So what is the data cloud when we talk about the data cloud? It's really a global network where thousands of organizations can mobilize to near unlimited scale, concurrency, and performance. So you think about when we say near unlimited scale, you think about object storage like Amazon S3, right? Think about some of the large customers that store literally petabytes of data distributed all over the world in S3, for example. Concurrency, being able to scale horizontally without interruption to other services. So I can scale from 10 customers or 10 people within my organization to thousands of people within my organization without having interruption in service. And then performance, being able to scale vertically. Right, I may have a workload today that as my data increases, I need more compute power to throw at that data to run more interesting and complex queries, analytics. If I'm using machine learning, running encoding to create matrices of that data. And so I need to be able to seamlessly scale out, scale up with near unlimited storage, right? So I'm scaling my compute and my storage simultaneously to meet that may fit for purpose and fit for use what my communities of interest require. And some of the core benefits, when we talk about access, govern, and action, we'll cover individually here in just a minute. And so at a high level, we're talking about data access. We're not talking about identity and access management. We're talking about access to your data, right? Having a single point of entry to all of the data within your organization. All of your structured data, all of your semi-structured data. So think about your JSON and your XML. And today, even your unstructured data. And so all of having an access to that point with a single point of entry, right? Within your organization, within your ecosystem of data. It could be within a business segment, or it could be within a community of interest, or even third-party data that you want to enrich your organizational data. When we talk about data curation and data enrichment, that's an important part of the data engineering data pipeline. Governance of your data. What do you have? You heard me mention a little while ago that building an ontology of your organization, right? And so, what data do you have and how does that relate to other data? One of the things I talk to customers a lot about is there's no such thing as non-relational data. We're talking about structured, unstructured, semi-structured data, but all data has a relation. Otherwise, it would have no value, right? And then data plus context is what equals that information. Protecting your data, having a single security model for all of your data, structured, semi-structured, and unstructured data. Complexity is the enemy of security, and so as you have to add more overlays of security to your data, and again, especially with zero trust and some of the other paradigms that are coming out, that's going to be critically important to be able to manage your data and separate that security of your data from other security concepts within your organization. Unlocking your data. When we talk about the 5 V's of data, volume, velocity, variety, veracity, the 5th one is value, right? Having value in your data, right? And part of value, for example, is being able to deliver that data that's fit for use and fit for purpose, right? If somebody within my organization needs to make a business decision every 5 minutes, and I can only get that data to them every hour, then I have no value. And so some of the concepts and technologies we're going to talk about in the data cloud, as far as data sharing, are going to be really important in delivering that value. And then action. Having product teams, data scientists, analysts, BI, business intelligence folks, accessing your data all simultaneously working off the same data set. I don't have to move data around. I can spin up environments. We talked about the scalability, virtually unlimited scalability, to be able to meet all of the needs of all those different communities of interest to access that data. So diving a little deeper into access, as I mentioned, we can really support any single point of entry for any format of data now, right? So we talk about structured, semi-structured, and unstructured. Structured being, your typical OLTP databases, right? Have normalized data models, and my transactional systems could be finance, logistics, whatever that may be, my ERP systems. JSON, XML, right? If we think about in the medical community, it was HL7 version 3, and now we've got FHIR, right? JSON, it could be different formats. FHIR could actually be in an XML format. We can support that. And one of the important things about that is because we can support those in standard ANSI SQL context, anybody with that SQL knowledge can go query those semi-structured data sets. It doesn't matter if you're getting multiple mutating schemas or things like that often happen in semi-structured data. And then being able to support unstructured data as well. So being able to support images, audio, textual analytics, which is really interesting. If you think about being able, again, going back to the medical example, a lot of doctors tend to use notes. And so if I want to derive information out of that, I might have to do something against that unstructured textual data to get information out that I need to marry up, create an ontological relation with the structured data that I'm getting in about a patient. And that's very powerful to be able to manage that in a single location. And so kind of moving out, you have your organizational data, you have your ecosystem of data. You think about your partners, suppliers, and customers. So if you think about supply chain management, say I'm building a platform, right? It could be a weapons platform. It could be, some kind of logistics platform, right? I've got to manage a supply chain. The more complicated that system is, the more vendors they have, and they might be spread out, in all sorts of places. And so I need to be able to not only share and access that data, and that's what the data cloud enables. And then the Snowflake Data Marketplace allows data to be published, and we'll talk about that, where other people can have access to that data either as open standard, open source data. It could be through some kind of security mechanism. We're even able to monetize that data. And so we're going to talk in depth about Snowflake's data sharing capabilities that enable the data cloud. Governance. We talked about knowing your data, right? And we talk about classifying your data. It's not about the classification of unclassified or secret or top secret. We're talking about understanding what your data is and how it relates to other data in your organization. It's pretty easy to understand that from a relational standpoint. We're talking about transactional systems or ERPs. But how do you relate to that with unstructured data coming in or semi-structured data coming in, where things like entity resolution become important, right? So it's really about unlocking the relationships in your data to be able to drive those organizational decisions. Unify security and governance. As I mentioned before, complexity is always the enemy of security. The more complex you make your security model, the more moving parts you have in it, the harder it is to make that ensure that's more secure. And so having a single unified security model for all of your data and separating that from your security model for like your identity and access management, being able to federate that access is hugely important from just securing your data. Encrypting your data, right? One of the really interesting features about Snowflake that really sets it apart is all your data is always encrypted. We don't allow customers to store unencrypted data. And so from a security standpoint, all of your data that's stored within Snowflake is always going to be encrypted. You don't have the option of not encrypting it, which is what I would always advise customers to do anyway. You also, all of your connections to Snowflake are going to be encrypted via TLS 1.2. And so Snowflake doesn't allow unencrypted transport of data and unencrypted storage of data. And so unifying that security and governance model where there isn't a knob to turn or the customer has to think about that, already having that place is hugely important from a security perspective. And then controlling your data, being able to sharing that data with that security model in place to understand who has access to that data. Also being able to revoke access to that data from a single location, right? So we talk about sharing data is very, very important, but what about when we have to unshare data for a particular reason? And so it allows you to unshare data at a granular or a macro level, like a micro or macro level, from a single pane of glass, from a single security model. And so all those things are very important. We're talking about the governance of our data in the modern data cloud. Actions we hit on, right? There's a lot of different people that use our data and traditionally had to move data around, but now with the data cloud, we don't actually have to move that data around to be able to support all these communities of interest, right? It could be development teams, right? I want to do development work against my data, but I don't have to move the whole data set. I want to do analysis against that data, and so I might need to scale up my virtual warehouse, which we'll talk about in a little while. I might be a data science community. I want to do some type of ML ops, right? I want to integrate a partner tool to do, build machine learning models, train, build, and then update those models from the same data source. All that can be done with the Snowflake data platform enabled by the data cloud. And so it's really important to understand your communities of interest and how you're really allowing them to access that data at scale in a way that allows them to drive value back into your organization. So why is the data cloud exciting? Like, what does it lead to? It really leads to what's called a network effect, right? And you think about network graphs, right? You think about like a Facebook or a LinkedIn or, this person's friends with this person and this person knows this person. It really allows you, enables data discovery, right? It's one of the interesting things like, in making recommendations to customers that, hey, we know you're doing this in your business. This data may be of interest to you that's in our data marketplace. So that data cloud, that data sharing capability allows customers to not only share their data, but also allows them to discover data that may be of value to enrich the current data that they have within their organization. It makes it very easy for them to access that data in a secure way without having to go through all of the traditional data engineering and data pipeline of moving data around. And we'll talk about how we enable that in a minute. So this is an interesting slide because it really shows just within the last year, if you think about, we talked about network graphs, how that explosion of the data cloud has grown just within a year. We're talking April 2020 to April 2021. And you can see on the April 2020, there wasn't a huge amount of sharing going on. There's a single hub, and then fast forward a year later, and if you're familiar with the network effects of things, you tend to have hubs get created in networks where people tend to rally around certain areas, and that's what you're really seeing. But you can see just the explosion of the growth. To drill down on that a little bit, some of those are software companies that are sharing terabytes of data with hundreds of customers. And when I say sharing, they're not moving terabytes of data. They're just sharing that data through the data platform to enable their data cloud. COVID-19 data, that's pretty self-explanatory. Lots of research, lots of analytics being done on COVID-19 data. Financial data, right? So if I'm a financial company and I'm tracking stocks or doing analysis or something like that, I can share, perhaps monetize that data with other customers through the data cloud where I don't actually have to move that data. And so customers you can have access to live data as it's being produced within my own data platform. I can share that out in real time. And then there's thousands of companies I mentioned with suppliers, partners, and other business units. Supply chain management being one of the interesting ones that, as your supply chain, and I think with COVID-19 that's really come to light is supply chains are complex. There's a lot of moving parts. And the more I can share that data and make the access to that data, reduce the friction of access to that data, I can enhance that supply chain to the point where I have visibility end to end. And so data sharing, the data cloud, actually enables that in a way that really couldn't be done before because of the requirement to move data and some of the other restrictions that were around. So how does Snowflake do this, right? How do we share and collaborate in the data cloud? So I'm going to go over the 3 different ways that we're able to do that. So when you create Snowflake, you have an account. Just like when you create AWS, you have an account. Or with another vendor, you have accounts, right? And so within that account, I can create a share with other Snowflake customers, right? I have a Snowflake customer with another account. I can share a table, right? I might have a table of data. I might have a view. I might have something that I can share a view, or I can share that with that customer to allow them to access that data. And when I say shared, I'm not actually moving the data. I'm just allowing them access to the data from my own data platform. And so that's a huge differentiator, is the fact that that data never actually does get moved. And so that customer, that person on the other side of that direct share that subscribed to that data has access to that data that's live. Remember, I don't say real time because I might not be receiving that data in real time, but if I am, and I'm able to process that data in that object that I'm sharing, then that person on the other side of the share has access to that data, that live data, whenever I actually update the data in the object that I'm storing it. I can also create reader accounts in Snowflake. If I don't have a Snowflake, if I'm not a Snowflake customer, or I want to share data with a person or an organization that's not a Snowflake customer, I can create a reader account, create a share, and allow them to see that data, to access that data in Snowflake without having their own account. Data exchange, what I think is one of the more interesting things for the public sector, because the data exchange allows you to set up somewhat of a community interest data sharing amongst people within that community, right? So you could think about one of the interesting examples that I've worked with in the past is with FFRDC's federally funded research, or UARCs, University Affiliated Research Centers, where they do a lot of research with different government agencies. And it's not always easy to get that data from, say, government agency X to a particular university, right? But I don't necessarily want to put that data out there for the world to access. And so I can actually create a data exchange as an organization that I manage and allow other people to come in and access that data. So I can allow, a university, for example, that wants to do research on some government data I've collected. I can, through a security model that I'm managing through that data exchange, they can come search the exchange, they can request access to that data, and I can grant access to that data, or the data set, or the data, columns, rows that I want them to see, without having to actually move that data. And so it's hugely powerful to really enable communities of interest, within organizations and across organizations. Again, going back to the supply chain, I might create a data exchange for my supply chain, right, for all my partners in my business ecosystem, where I, as the program office, manage that data exchange. But I want all of my suppliers and my vendors within that data exchange to be able to have access to that data, how they need it and when they need it, based on the security model and who I designate as the owning program to have access to that data. So I think there's a lot of benefit from a data exchange platform within the public sector for a whole host of different use cases. And then the data marketplace, right? So I could also publish my data to the Snowflake data marketplace, and then people can come and search on that data, and I make it available for them to use. And that could be making it available for free. I could have that data available upon request, where I have to approve that. I could even monetize that data, right? So there's a lot of different, and that's, if I want to publish that data out to the world. So again, that could also be, you could use the research example for it as well. But the data marketplace, when you think about that graph, is really where you have, in the data exchange, a lot of those connections take place. And again, with both the data exchange and the data marketplace, I don't have to move the data anymore. I can publish that data, allowing those communities of interest to access that data, when they need it and how they need it, in a secure way. And so it's a huge differentiator from the traditional, kind of data ops, where you have to move data, FTP or, other methods and stuff to be able to share that data, right? Today, I can allow customers in a secure way to access that data, either through an exchange that I've set up and I manage, or through the marketplace, to allow them to go search and use that data as needed. And so there's a lot of value in that data sharing to enable the data cloud through the Snowflake data platform. So a little bit about Snowflake and talk about, so, when we talk about the data pipeline, data operations, right? We talk about, I mentioned before, one of the first things you notice is data warehouse and data lake, right? The data platform is worried about the convergence of that, right? Being able to store any data at any volume, at any velocity, right? And so data warehousing is pretty self-explanatory, right? I've got a transactional system that I may be running a CDC tool against. Use like AWS DMS, for example. And I'm capturing changes from my database logs, and I'm pulling those into my Snowflake data platform. Pretty straightforward. But I also want to be able to use it as a data lake, right? I've got images coming in. I've got signals coming in I want to do some analysis against. I've got text coming in I want to do something. I've got audio coming in I want to do something with. Now I can also store that on the Snowflake data platform as well. So what I think you're really seeing is the convergence of the data warehouse and the data lake, and that's really what we mean by the data platform, which is what enables the data cloud. All of my data engineering can be done within Snowflake today. And so Snowflake's 100% ANSI SQL compliant. And so all of that can be done within the Snowflake engine and the virtual warehouses, which we'll discuss in a minute, at any scale, right? And so I can run, small jobs, large jobs, batch jobs, micro batch, mini batch, streaming. I can process all of that data within one location, right? I don't have to move that data around anymore. And again, we talked about data exchange. I can set up a data exchange where I want to share that data with other communities of interest and create that community exchange from the data platform. Data applications, we talk about, you'll hear us talk about powered by Snowflake. There's a lot of applications out there that run dashboards or run things that are real-time, processing data real-time that deliver that to customers' own applications that then they go deliver to their customers. And so there's a huge ecosystem of data applications that are powered by Snowflake. And then the data science community, which is, which I deal with a lot and working and building out, taking that raw data input. If you think about data as a manufacturing process, taking raw input and building data products for that data science community. People always talk about the data processing or the data manufacturing as being 80% of the work. And really the job from a data engineering standpoint is to obfuscate that from the data science communities. They don't have to do that, right? If you're a statistician, a logistician, if you're a geneticist, right, you don't necessarily want to be doing that, right? You want to have the data product built so that you can do that. And that's really what the Snowflake data platform and the data cloud allows, is to build those data and information products to be able, your communities of interest, who are those logisticians, statisticians, BI analysts, to use that without having to do all that work that today is consuming a lot of their time. And then you have your data consumers, which we hit on, monetizing your data, operational reporting, being able to scale to do ad hoc analytics, right? I don't have to worry about resource contention anymore on the Snowflake data platform because I can scale horizontally, I can scale vertically, depending on the requirements without hindering other people within my community, right? So I may be running a query that takes have to scale up, takes a lot of compute, but then I may have other people that need to do more concurrency, right? I have more concurrent BI users that need to do more stuff. I can do that seamlessly without interrupting other people, having the noisy neighbor problem. And then real-time analytics, we talked about that. If I wanted to do pure streaming and I wanted to publish that data out, I could do that as well. So a brief overview of the architecture that enables that. So you'll see in the middle, we're going to work ourselves out as centralized storage. And one of the unique things about Snowflake is storage and compute are completely decoupled, right? And so my centralized storage, my object storage, can really scale data at any volume, velocity, variety, right? I can store anything there, right? On top of that, I've got my compute clusters, right? And so I need compute, right? When I run a query, when we think about when we submit SQL to run a query, I need an engine to run that, right? And so my compute clusters, I can scale, I can deploy as many virtual compute clusters as I want to on top of that storage. I can deploy, 10, 20 clusters on top of that to do whatever the workload requires for my communities of interest. So I might have a cluster that's doing ETL. I might have a cluster that's doing BI. I might have a cluster that's doing X. I might have a cluster that's feeding an ML ops pipeline, right, to build models, right? I could do all that on top of the storage, centralized storage, because of that disconnect in between, that separation between my compute and my storage, right? And so that's hugely powerful to be able to do that. The other interesting thing is now I can optimize the cost of that storage, right, the cost of that compute by being able to shut that compute down when I'm not using it. And so that's one of the things from a data sharing perspective, right? If I'm sharing that data and somebody's coming in and using that data, they can actually do their calculations, do their queries, do the work that they run their workload, and then shut that down, right? They don't have to pay for it in perpetuity. And so there's a lot of things that can be done by separating storage and compute and having that virtual warehousing layer that you traditionally couldn't do, that enable the data platform and the data cloud. And on top of that is our cloud services layer, right? Where I'm doing the management plane, or I'm doing identity, security, right? Role-based access control, parsing, and a lot of things that go on. And so what we've done from a compute perspective is move some of those things that I don't necessarily need in the compute up to the services layer, so that my compute layer can purely be used for and take advantage of query optimization. And so really, if you look at the architecture, that centralized storage, going back to that, is really what drives the data sharing. Because if I'm sharing that data, the person that I'm sharing that data with can spin up their own compute clusters, right? Their own virtual data warehouses, and run it against the storage, the object within the centralized storage that I'm sharing with them, right? And it applies to the data exchange model. It applies to the data marketplace model as well, right? So having that separation of compute and storage, allowing customers to access that centralized storage with their own virtual data warehouses that they've spun up, is really the driving differentiator, the uniqueness that enables the Snowflake data platform and the data cloud. With that, I thank you for your time in attending the summit with this session. If there's any questions, please feel free to contact your Snowflake representative.